Hi everyone, hope you all are doing very well. Welcome to GATE 2025 live classes. The subject for today is Water Resources Engineering and the topic for today is crops and crop requirements. So firstly we will be discussing about the theoretical concepts related to this, and to the end we will be solving a few problems also. So this is a very basic topic yet an important one for GATE examination. So let us start and see what are the different crops in India and the crop seasons in India. So we will be discussing about mainly 4 crops here: rabi crops, kharif crops, zaid crops and perennial crops. So trust me, it is very important to be aware of these crops, because when we are solving numerical problems, we should know whether the two crops are belonging to the same season or they are of different season. So awareness of the various crops and their examples are very crucial for solving numerical problems. So let's start and see what are the features of rabi crops. So rabi crops are popularly known as winter crops because, as the name suggests, they are sown in the autumn season. And in India, the average autumn period is from September to November. That is the average of all the states. And it is harvested in spring, that is from February to March. So you should know about the time period. From September to November, it is autumn, and from February to March, it is spring. And a few examples of rabi crops in India are wheat, potato, tomato, mustard, gram, onion, garlic, oats, barley, sunflower, etc. So why these examples? Because in previous GATE questions we have come across the mustard and gram as examples to solve the problems. So when a problem is given and you are told that one crop season or one crop is mustard, the other one is gram, you should know that both of them belong to the rabi season. That is, you are cultivating the same crops, or you are cultivating rabi crop, two rabi crops. It belongs to the same season, and therefore the discharge requirements may vary. So if you are providing water to the crops belonging to the same season, it is different. If it belongs to the different season, you have to take it differently. So that is why we should be aware of some of the rabi crops which are grown in India. So wheat is the main cereal that is grown under rabi crop. Wheat, potato, tomato, mustard, gram, oats, barley, sunflower, etc. And in general, if we see, the water requirement is generally less for a rabi crop compared to a kharif crop. Kharif crops requires more water compared to rabi crop. So let us see what are the features of kharif crops. So kharif crops are popularly known as monsoon crops, and as the name suggests, it is sown in southwest monsoon. The seeds are sown in southwest monsoon, that is the average time period is from July to September, and it is harvested in autumn. As we have already seen, the autumn season is from September to November. And the main examples involved are rice, that is the most important example. Rice, groundnut, cotton. Cotton, again, you have to be careful. Cotton comes under kharif crop. It is not a perennial crop. It is harvested or it is cultivated in a time span of around 240 days or 260 days. So it is not perennial. It comes under kharif crop. So cotton, soybean and all the millets, basically maize, jowar, bajra, ragi, all belong to the millet family. They are also examples of kharif crops, and again turmeric, brinjal, etc. All these are examples of kharif crops. And you have to note that in general, kharif crops requires 2 to 3 times more water than a rabi crop. Okay, as I've already mentioned, rabi crops generally doesn't require so much of water, but kharif crops requires 2 to 3 times more water than a rabi crop. So that is a very important point, because if you are supplying the same amount of water to a rabi field and a kharif field, you can cultivate only a small area in the kharif field, because it requires 2 to 3 times more water than rabi. So if you are cultivating or if you are irrigating 1000 hectares of land in rabi, then you can approximately cultivate around 500 hectares in kharif, because it requires the double water or twice the water as a rabi. So that is a very important point you have to note. Kharif crops requires 2 to 3 times more water than a rabi crop. Okay. Now let us move into the third season, which is the Sayat crop, also known as summer crops. So we all know that we have a summer season in between. Between Rabi and Kharif, we have a summer season, and there are various crops which are grown during these hot weather season. That is the interval of March to June. That is popularly known as the Sayat season. So it is cultivated during the interval between Rabi and Kharif season. And the famous examples are, as we all know, pumpkin, cucumber, watermelon. We all consume a lot of watermelon during the summer season. So it is basically a summer crop. So you can call it as a summer crop, also hot weather crop. You may come across these names in numerical problems. So hot weather crops. Sayat crops or summer crops or hot weather crops, which is cultivated during an interval from March to June. Coming to perennial crop. So as the word suggests, you know, the meaning of perennial is throughout the year. So if I say a perennial river, what does that mean? Water is available throughout the year. That is, it doesn't dry up. That is a perennial river. So the word perennial indicates something which is available throughout the year or something which happens throughout the year. That is known as a perennial. So perennial river means water is available throughout the year. Perennial irrigation means you are supplying water throughout the year as per the requirements. So here we are discussing about perennial crops. So that means it takes 1 full year for maturity. So previously we have seen Rabi, Kharif, Sayat. All these are a time period, or all these comes under a time span of 6 months or 3 months. It is seasonal. But perennial crops takes 1 full year for maturity. That is around 360 to 365 days are required to attain maturity. And the best example for a perennial crop is sugarcane. It approximately takes 360 days to attain maturity. And certain fruits and vegetables also comes under the perennial category. So when I say certain fruits and vegetables, there are many exceptions. Some fruits may take 3 or 5 years to harvest. Some may take 2 years, and some vegetables may take less than a year. They may be able to harvest in a 6 months period or a 4 months period. So there are exceptions, but you can say certain fruits and vegetables comes under perennial crop, but the major perennial crop is sugarcane. Okay, hope I am clear. Now moving on. So we have discussed the main 4 crops: Rabi crops, Kharif crops, Sayat crops and perennial crops. And all these crops comes under 2 categories. They can be either a dry crop or a wet crop. So what is a dry crop and what is a wet crop? Crops which can be grown without irrigation water. What do you mean by irrigation water? The water which we are artificially supplying to grow the crops. So the subject irrigation itself indicates the process of artificially supplying water to the soil for raising crops. So if you can grow a particular crop without irrigation water, then you can call it as a dry crop. Obviously, Rabi crops, most of the Rabi crops are dry crops. Wheat, barley, sunflower, they are all dry crops. You can grow it without supplying artificial or without supplying additional water. It can grow, basically it can grow up to a few centimeters with the soil moisture itself. But if you are commercially growing a crop, then definitely you will be applying fertilizers, you will be applying a lot of other things, and it requires a more amount of water. Okay, so crops which can be grown without irrigation water is known as a dry crop, and crops which cannot be grown without irrigation water is known as a wet crop. And the best example is rice. Rice cannot be grown without artificially supplying water. And the best example for a dry crop is wheat. Sunflower, again sunflower, oats, barley also comes under dry crop. So just note the difference. One can be grown without irrigation water, other cannot be grown without irrigation water. So in general, we can classify all the crops to be either a dry crop or a wet crop. Now coming to an important ratio, crop ratio. It is the ratio of area irrigated in Rabi season to the area irrigated in Kharif season. So any idea what this ratio would be? Just take a guess. We already discussed that Kharif crops requires 2 to 3 times more water than a Rabi. And so what happens is, if you are applying the same amount of water to a Rabi field and a Kharif field, for example, you are applying 50 cubics of water to Rabi and 50 cubics of water to Kharif. So using this 50 cubics of water, you may be irrigating 100 hectares of land in Rabi. But with the same amount of water, you can only irrigate around 50 hectares in a Kharif field. That is because the Kharif crops requires more water, or twice to thrice water than a Rabi crop. So the approximate ratio or the crop ratio will be 2:1. That is, if you can irrigate 2 units of land in Rabi crop or in a Rabi field, you can only irrigate 1 part of the area in a Kharif season. So crop ratio is area irrigated in Rabi season divided by area irrigated in Kharif season. Okay. Now moving on. So we have discussed about the various crops and crop season, and by now you know the examples also. Now we will be moving further and we will be dealing with other requirements also. So basically, during cultivation or a growing season, we have divided the growing season into 2 time periods, crop period and base period. So the time or the total time for which a crop remains in the field is known as crop period. Just take a guess. So we are sowing the seeds. That is the first time a crop is introduced into the field, right? Okay. So the time from the instant of sowing to the instant of harvesting, that is known as a crop period, right? So that is the total time for which a crop is remaining in the field. We are introducing the crop into the field at the time of sowing, and we are removing it from the field during harvesting. So the time between the instant of sowing to the instant of harvesting is known as crop period. So what will be a base period? Base period is basically the time interval between first and last watering. So can you guess when we will be providing the first watering to the seeds? At the time of sowing. So the time between the first watering at the time of sowing to last watering before harvesting. So imagine if you are harvesting the crop during the first week of June, then we will be providing the last watering a few days back, right? We won't be watering it at the day of harvesting. There is no need for that. So the time between the first watering at the time of sowing to the last watering before harvesting. So definitely base period is greater than crop period. You should know that relation. Base period is greater than crop period. Sorry, crop period is greater than base period. Because crop period is from sowing to harvesting and base period is from the first watering to last watering, which is before harvesting. So definitely crop period is greater than base period, and base period is denoted by capital B. So we will be using only base period in the further problems because we are dealing with the subject irrigation or water resource engineering. So in irrigation, we are talking about the artificial supply of water to crops. So we will be dealing with base period only. That is the important term in irrigation. Okay. So I hope the difference between crop period and base period is very clear. Now coming to the most popular term in irrigation, that is duty. So I will be explaining this concept using the unit of duty. So you all know that the unit of duty is hectares per cubic. What is hectare? It is a unit of area. We all know that 1 hectare is equal to 10 raised to 4 meters square. You should always keep this in mind for solving the problems. So, hectare means area. What is 1 cubic? 1 cubic is equal to 1 meter cube per second. That is the unit of discharge. So, basically from this unit, you can derive a ratio or an equation, that is duty is equal to area divided by discharge. This understanding is very important while solving the problems. So, duty is basically area divided by discharge, and the unit of area used here is hectare, which is 1 hectare is equal to 10 raised to 4 meters square, and discharge unit is cubic, that is 1 meter cube per second. That is, you are applying 1 meter cube volume of water in 1 second, that is 1 meter cube per second. Clear? So, the unit of duty is hectares per cubic, or you can say duty is equal to area divided by discharge. Now, I will explain what exactly is duty. Using 1 cubic of water, the total area in hectares which you can irrigate, that is known as duty. That is, you have 1 cubic of water in your hand and you are irrigating, or you are supplying water, this water to the crops. So, what is the maximum area in hectares which you can irrigate using 1 cubic of water? That is known as duty. So, you don't have to by heart these definitions. You just have to look into the unit and explain what is duty. So, I will repeat once more. The maximum area of land in hectares which can be irrigated using 1 cubic of water. That is what is exactly duty. Okay, or you can say that it is the irrigation capacity of water which you have. So, that is also a previous question in various examinations. Irrigation capacity of water indicates dash, that is duty. The area of land in hectares which you can irrigate if you have 1 cubic of water, or using 1 cubic of water. So, I want to ask you something. The duty will be highest for Rabi or Kharif? Can you say? We already discussed about Rabi crops and Kharif crops, and you know which crop requires more water. So, the duty will be highest for Rabi or Kharif. Just look at the ratio. It is area divided by discharge. So, a Kharif crop requires more water compared to a Rabi crop. So, using 1 cubic of water, you can only irrigate a few hectares for a Kharif crop, and you can irrigate more area in a Rabi field or for a Rabi crop. So, duty will be always highest for a Rabi crop compared to a Kharif crop. We can see a few examples also. So, just see. We all know that rice is a Kharif crop and wheat is a Rabi crop. So, just have a look at the duty. Using 1 cubic of water, you can irrigate 900 hectares of land in a Kharif crop or in a rice field. But using the same 1 cubic of water, you can irrigate 1800 hectares for a Rabi crop. So, that is exactly what I was telling. So, what is the maximum area you can irrigate using 1 cubic of water? That is duty. So, if you can irrigate maximum area using 1 cubic of water, then it has the highest duty. So, as the water requirement increases, duty decreases. Is that clear? Hope it is very clear to all of you. So, I have just come, you don't have to by heart these values. I am just showing an example to prove that the duty is highest for a Rabi crop and it is less for a Kharif crop. So, for any crop or any situation which requires more water, the duty goes down. You can use this as a tip for examination. If the crop requirement or the water requirement goes up, duty goes down. If the losses of water increases, also duty goes down. You should have a basic idea about that. Okay, so coming back, I just want to summarize. If you are asked about duty, if someone asks you what is duty, first thing you should tell is the unit of duty. The unit of duty is hectares per cubic. That is area divided by discharge. The maximum area in hectares which can be irrigated using 1 cubic of water. So, hope duty is very clear to all of you. Don't forget the unit, that is very important, because we will come across a lot of problems that involves duty. This basically area by discharge. Now coming to delta, the total depth of water that is required for the complete growth of a crop, that is known as delta, because when you sow the seeds, after a few days the crops will be coming out. It will be coming out from the soil and you will be watering it. You require a very few amount or a very little amount of water during the initial stages, and as it grows up you require more and more water. So, to complete the harvesting stage or to complete the full maturity, what is the total depth of water that must be applied for the entire season or for the complete growth of a crop? So, definitely the unit will be meter or centimeter or millimeter. You can represent delta in any units of depth, meter, centimeter, millimeter or any other unit. So, what is basically delta? The total depth of water required for the complete growth of a crop. And it's very important that we should know certain delta values for different crops. It was asked in the previous GATE examination also. So you all know that there will be a pattern of questions like match the following for GATE examination. So delta of wheat was asked in a previous examination. So you should minimum, for a bare minimum, you should know at least these 4 values for delta. For rice and sugarcane, the delta value is 120 centimeter. For wheat, it is 40 centimeter, and for cotton, it is 50 centimeter. So, wheat was asked previously in GATE examination, as I have already mentioned. So, please note these, at least these 4 values should be aware to you. Rice is 120 centimeter, sugarcane is also 120 centimeter, wheat 40 centimeter, and cotton 50 centimeter. So, the unit of duty is hectares per cubic and the unit of delta is meter or centimeter. Keep in mind. Okay. So, you all know what is duty. You don't have to by heart the definition. You should think about the unit and derive the meaning from that. Hectares per cubic. That means using 1 cubic of water, how many hectares of land you can irrigate. And delta, the unit is meter or centimeter. So, that is basically depth. The total depth of water that you must supply in order for the complete growth of a crop, that is delta. Moving on. Now, let us see the relationship between duty and delta. Here is where we are going to apply the equations for problems. So, the relation between duty and delta, this is a very famous relation. Delta is equal to 8.64 B by D. You all know that B stands for base period and D stands for duty, and the unit is hectares per cubic. The unit of base period is days and delta is in meter. So, if you are substituting 8.64 B by D, delta will be in meter, base period will be in days and duty will be in hectares per cubic. You can also use this equation. Delta is equal to 864 B by D. The only difference is delta is in centimeter, B will be in days, that is base period in days, and duty will be in hectares per cubic. Okay. So, obviously we will be applying this equation to many problems. So, you have to learn this equation. It's very important. 8.64 B by D where delta is in meters, 864 B by D where delta is in centimeters. So, we will be discussing about the problems to the end. I will be discussing a very few problems, standard problems which were asked previously in GATE or ESA examination to the end. So, first we will be completing the theoretical concepts and then we will be moving on to the problems. Now, we are dealing with another 2 terms which will be seen in various problems, paleo irrigation and core watering. So, paleo irrigation means the first watering before sowing the crop. So why are we applying water before sowing? That is, we are providing a basic moisture to the soil. So paleo irrigation is basically applied for the soil and not the crop. So the first watering before sowing the crop is paleo. That is basically for land preparation. We are preparing the soil before sowing. So that there is a basic retaining capacity of moisture in the soil. For what to say, providing a minimum moisture to the soil so that it has a holding capacity. We can get higher duty if you do paleo irrigation. So paleo irrigation is basically for land preparation. So what about core watering? Core watering is the first watering which is given to a crop when it is a few centimeters high. So the difference is both are first watering but during different stages. Paleo is the first watering given before sowing and core watering is the first watering given when the crop has been a few centimeters high. That is after sowing, when the crops comes out, you are giving the first watering. So don't confuse between these two terms. Both are first watering but during different stages. One is before sowing the crop, that is called as paleo, and one is when the crop is a few centimeters high, that is known as core watering. And here also we should be aware of the core depth values, because the depth of water provided during the core period is different. We have studied about the total delta value. For example, the total delta for the rice is 120 centimeter. But during the initial stages, we will be providing a depth of 19 centimeter for rice or 190 mm. So the core depth of rice is 19 centimeter. Wheat, it is 13.5, and for sugarcane it is 16.5. So you should be aware of the core depth values as well as the total delta values. So I hope it is clear what is the core period. The time period for which core watering is done is known as core period, and the total depth of water provided during the core period is known as core depth. For rice it is 19, wheat 13.5 and sugarcane 16.5. So this is all about the crop period, base period, duty delta and the standard values. Now we will be discussing about another concepts. So here you can see a canal, a comparatively large canal which is flowing, and both sides we have different areas which is distributed around the both sides of the canal. So we will be discussing about gross commanded area, GCA. So if you have a canal system, what is the total area that can be irrigated using the canal system? So if we come back to this figure, so here we have a lot of area one side, and there also we have a lot of area spread out on the other side. So if you see, this canal has access to both the sides, correct? But it is not necessary that both the sides are completely irrigation field or agricultural field. There may be houses, there may be private properties, there may be forest area, there may be ponds, wells, roads, there may be different area. So GCA just indicate where all we have access with this canal water. So total area which can be irrigated by this canal system is known as gross commanded area. For example, the gross commanded area may be 1000 hectares. It doesn't mean that 1000 hectares of agricultural field are there. No, 1000 hectares, for a total area of 1000 hectares, this canal can supply water. But these 1000 hectares may contain different aspects of area. There may be houses included in this 1000 hectares, forest area that may be distributed in a different way. But we are just looking into the total area which has access to this canal water. That is known as gross commanded area. The total area which can be irrigated by a canal system or a dam or an irrigation project, also known as Ayakat. Okay, hope it is clear. Now let us see what are the areas included in a gross commanded area. So if you take a GCA for an irrigation project, it may contain all these portions. Cultivable land, land which is very ready for cultivation or agriculture. You can start cultivation, you can grow different crops in that area very smoothly. So that is known as a cultivable land. A land is very much ready for cultivation. Pastures, we all know that grazing fields where we take cattle for grazing. So that is known as pastures, which is also a very good soil, which has very good soil and which is ready for cultivation. Fallow land. A fallow land means a land which is left uncultivated for more than 1 year and less than 5 years. There had been cultivation, but for more than 1 year it is left uncultivated, but the soil is still good and you can still start cultivation there. So, fallow land means a land which is left uncultivated for more than 1 year and less than 5 years. So, basically these three areas are fit for cultivation and you can call it as cultivable area or culturable areas. Clear? Cultivable land, pastures and fallow land are fit for cultivation. The soil is good and you can start cultivation there anytime. So these three comes under culturable areas. But coming to wasteland, a land which is left uncultivated for more than 5 years. So if you are not cultivating there for more than 5 years, what happens? The soil loses its fertility. That is, the soil is not good right now. You can't go and cultivate there right away. You have to do a lot of measures to make it cultivable. So wasteland means basically barren land, land which is left uncultivated for more than 5 years. Fallow land was left uncultivated for more than 1 year and less than 5 years. But wasteland is left uncultivated for more than 5 years. So basically it is not fit for cultivation right now. Now, forest or protected area. We know that the soil in the forest is extremely good. It is fertile, it is fit for cultivation, but it is a protected area. You cannot clear the forest and practice cultivation. So, forest or protected area, you can't do agriculture or cultivation there. Roads. Obviously, we cannot grow crops in roads, houses, ponds, etc. So, all these comes under unculturable areas. Now, you have a clear idea about what a GC is. The total area which has access to irrigation water, that is called as GCA. But it includes both culturable areas as well as unculturable areas. So obviously if you want to cultivate a crop or you want to grow a crop, then you should choose these three areas: cultivable land, pastures or fallow land. So GCA is a sum of culturable areas as well as unculturable areas. Now coming to culturable commanded area, CCA. The area where actually cultivation can be done, that is known as CCA. So if we come back to the list again, in this particular list, these three includes CCA. That is, GCA minus unculturable areas is called as CCA. The area where actually cultivation can be done. Definitely you cannot cultivate on wasteland or forest or houses or roads or ponds. So the area where actually you can do cultivation or you can grow crops is known as culturable commanded area. And the equation is CCA is equal to GCA minus unculturable areas. Now, I hope you really know the difference between GC and CCA. So, if you are constructing a canal system, it has access to both the sides. So, the total area which has access to this canal water can be called as GCA. But that doesn't mean these areas, all these areas can be cultivated. So, the areas where actually cultivation can be done is named as culturable commanded area. That is GCA minus unculturable areas. And here comes another classification: culturable cultivated area and culturable uncultivated area. So, imagine you have 500 hectares of CCA. Okay, and during a particular season, we only cultivate half of the area or 40 percentage of area or a portion of the area. So, portion of CCA which is actually cultivated during a crop season, that is known as cultivable cultivated area. For example, we are dividing this area into two. You are cultivating 250 hectares of land during a particular season and 250 hectares is left uncultivated. That means the portion which is uncultivated is known as culturable uncultivated area. Why do you practice like that? That is to maintain the fertility of the soil and to maintain the soil moisture. If you are continuously cultivating 500 hectares throughout the year, what happens is soil loses its moisture balance, its fertility, and it will be good for nothing in a couple of years. So, you don't do that. You cultivate for a particular portion in a season, the other will be given rest or other will be remaining in rest for the season. For the next season, you will be cultivating in that particular area and you will be giving rest to the other portion. That is why it is divided into culturable cultivated area and culturable uncultivated area. So, for a particular season, it is not necessary that you have to take 50%, 50-50. It is not necessary. You can also go for 300 hectares and 200 hectares, which means that for a 300 hectares, you will be growing crops in a particular season, 200 will be remaining uncultivated. For the next season, you will be cultivating in the 200 hectares and 300 hectares will remain uncultivated. So, basically you are giving rest to some portion during one season so that the soil can recover its moisture balance, its fertility, etc. So, I hope this portion is very clear to all of you. Gross commanded area means the total area which has access to a irrigation project or access to irrigation water. The actual area where cultivation can be done is known as CCA, cultivable commanded area. And among or in within this CCA, only a few portion is cultivated during a particular season, the remaining is given rest. So, the portion where actually cultivation is taking place during a season is cultivable cultivated area and the area which is remaining in rest is known as cultivable uncultivated area. Okay. Now, moving on. Intensity of irrigation. Now, this is very important for problems because you will be coming across this word in almost all the problems. They will be saying that the intensity of rice is so and so, the intensity of wheat is so and so, etc. So, what is basically intensity? So, I will explain this using an example. Imagine in Rabi season, we are cultivating 70% of CCA. We already discussed we will be cultivating a particular area and the remaining will be in rest. So, 70% of CCA is cultivated during Rabi season. And during Kharif season, we are cultivating 40% of area. Okay. So, in a year, we are basically considering two seasons, Rabi season and Kharif season. You have cultivated 70% of CCA in Rabi season and 40% of CCA in Kharif season. So, what is the annual intensity? The annual intensity is equal to 70 plus 40, which is 110%. Now, I will explain what is intensity. The percentage of CCA irrigated annually. I have highlighted the word annually. That is the sum of all the portions which has been cultivated during 1 year. So, that is 70 plus 40 is equal to 110%. Please note, it can be more than 100% because it is the sum of all the percentage of CCA during 1 year. So, if you are considering one season, it will be definitely less than 100%. But during 1 year, you will be taking the sum of all the seasons or all the percentage of CCA which has been cultivated. I hope it is clear. So, intensity basically indicates area. You are talking about area. The percentage of CCA which is proposed to be irrigated during 1 year or annually. So, it can be definitely greater than 100%. So, it is very important while doing problems, you will be asked to find out the annual intensity. So if you are asked to find out the annual intensity, what you have to do is, you have to just take the sum of percentage of CCA which was cultivated during all the season. Here in this example, I have only mentioned about the 2 season. You have a summer season also. So for example, if there is a summer season in which 30% of CCA was cultivated, then the sum comes up to 140%. Clear? So that word is very important. It is the percentage of CCA irrigated in 1 year, and that is why it can be greater than 100%. So such points can be asked in true or false statement questions also. So please be careful. Now we are coming to certain efficiencies which are also very important in solving problems. So basically, what is efficiency? In any system, it is the ratio of output by input. You have given something, or you have applied something, or you have given some input, and what is the output you are getting? So if you want 100% efficiency, the output and input should be the same. You are providing so much and you are getting that much. Okay. So let us see some of the efficiencies required in this subject. Water conveyance efficiency. So definitely we are taking water for a canal system. We are taking water from a river or a lake or a dam. We will be taking water. So some amount of water is taken from the river and it is transported to the field. So imagine if you are taking 100 cubics of water from the river and you are supplying this water to the field using a canal system. So definitely you are not getting 100 cubics in the field. So 100 cubics will be supplied from the river, that is transported through the canal system, various losses takes place, and sometimes 70 cubics will be reaching the field. This is known as conveyance efficiency. The amount of water supplied from the river and the amount which was actually delivered to the field. This is known as conveyance efficiency. The water delivered to the field divided by water supplied from the river. So obviously you can't get 100% here. You have to compensate for the losses. So if you want 70 cubics in the field, definitely you should take more than that from the river. Then only you can compensate for the losses that are taking place during transportation. Clear? So water conveyance efficiencies, you are taking some amount of water from the river, and from that amount, after all the losses, some amount has reached the farm. So water delivered to the farm divided by water supplied from the river into 100. Now you have delivered some amount of water to the field, but it's not possible that the root or the plants get that full amount of water. So water application efficiency means the water which was delivered and within that how much water was obtained by the plant. So water stored in the root zone divided by water delivered to the farm into 100. I hope that is very clear. Initially you are taking a particular amount of water from the river, and from that amount losses has been deducted and a particular portion was delivered to the farm. So if you are delivering 50 cubics of water to the field, definitely the plant is not going to get the 50. It will be having various losses in the field itself, and maybe 25 cubics has been obtained by the plants. So water application efficiency means the water which was actually stored in the root zone divided by water delivered to the farm into 100. Now coming to water storage efficiency. So we have told that we delivered some amount of water, the plants got a portion of it. But we also know that certain crops require certain amount of water. For example, the total delta for rice is 120 centimeter. So we have to ensure that the plant gets what it requires. So storage efficiency means the water stored in the root zone divided by water actually needed in the root zone. For example, the water actually needed in the root zone is 90 centimeter. And while we are applying water, it got only 70 centimeter. So this is not enough. So water storage efficiency should be 100% because for the complete growth of crop or maturity of the crop, if it requires 90 centimeter, you should ensure that it gets 90 centimeter. So that is all about water storage efficiency. The water actually stored in the root zone divided by water actually needed in the root zone into 100. Clear? Now coming to water distribution efficiency. So distribution efficiency means the efficiency in distributing water to all the points in the field. So maybe you will be supplying water through a single channel system for a single channel running through the field. So you must ensure that this channel is able to provide or distribute water uniformly to all the areas or to all the points in that particular field. So it is 1 minus y by d into 100. So d means the average depth of water stored at the various points, and y is the average numerical deviation from the depth of water stored. So definitely this should be 100. To be 100%, the y or numerical deviation should be 0. There shouldn't be any deviation. So if you are dividing the land into plots and you are supplying water to each plot, we should ensure that each of the plot gets water uniformly. So the average depth of water stored in these plots is small d, and the numerical deviation from the average depth of water stored is y. So if we want 100% efficiency, there shouldn't be any deviation. All the plots should get the same depth of water. Then only we can ensure proper harvesting and proper growth of crop. I hope the 4 efficiencies are very clear to you. I would repeat. Conveyance efficiency means the transportation efficiency. You are supplying water from the river to the field through a canal. So water taken from the river and water which was delivered, that comes under conveyance. You have delivered some amount of water and a portion of it was stored in the root zone or absorbed by the plants. That comes under application efficiency. Next, coming to storage efficiency, some amount of water was stored in the root zone, and was that equivalent to the water which was actually needed in the root zone. That comes under storage efficiency. And last one is distribution efficiency. You have delivered some amount of water to the field. Was it distributed uniformly to all? So if every crop requires or every crop has attained uniformly the water which was distributed, then you can have 100% efficiency. Okay, so now let us discuss a few problems related to theory what we have studied. So first problem is from GATE 2023 and it is a numerical answer type question. So let me introduce to you what is a NAT question. Numerical answer type question which has no options. Usually MCQ questions or multiple choice questions will be having 4 options A, B, C and D or 1, 2, 3 and 4. But here you will not be given any options and there are no negative marks also, which is a highlight. So here what you have to be careful is that you will be instructed how to write the answer to exact how many decimal places and all. So you should be writing the answer particularly or accordingly, then only you will get full marks. So there are no negative marks, you can freely attempt such types of questions. So let us see what this question is all about. A canal supplies water to an area growing wheat. So we are growing wheat over 100 hectares. The duration between first and last watering is 120 days and the total depth of water required by the crop is 35 centimeter. The most intense watering is required over a period of 30 days and requires a total depth of 12 centimeter. Assuming precipitation to be negligible and neglecting all losses, the minimum discharge in the canal to satisfy the crop requirement is. The concept is we are supplying water to the field using a canal system. So we are told that there is a period of intense watering for a period of 30 days and the remaining days requires normal watering. So we are asked what should be the capacity of the canal or what should be the minimum capacity of the canal to satisfy this crop requirement. So we are going to divide the entire base period into 2 stages. What is the total base period? It is 120 days. Now we are going to divide this 120 days into most intense watering time period and the remaining time period. So most intense watering is required during a period of 30 days. So what is the remaining days? 90 days. Because we have a total of 120 days. During 30 days you are providing intense watering, and for the remaining 90 days you are providing normal watering. So during this 30 days you should provide a depth of 12 centimeter. Now we are going to find out the discharge required during this 30 days and the remaining 90 days. So let us see how to solve this problem. So first we are going to consider the period of 30 days. So this is the discharge required during 30 days. And this is the discharge required during remaining 90 days. We are dividing the whole base period into 2. So during the first 30 days, using the equation 864b by delta, you can find out the duty for 30 days and a depth of 12 centimeter. You get the answer as 2160 hectares per cubic. Now, to find the discharge, we all know that duty is equal to area by discharge. So, discharge is equal to area by duty. So, we get a discharge of 0.046 cubics. That is, during the first 30 days, you require a total discharge of 0.046 cubic. Now, for the remaining 90 days, we are calculating. So, 90 plus 30 is equal to 120. So, remaining is 90 days. And we know that total depth of 35 centimeters required for the complete growth. Already you have provided 12 centimeter. So for the remaining days you are going to provide 23 centimeter in 90 days. So the duty obtained is 3380.8 hectares per cubic. And the discharge required during this 90 days is 0.029 cubics. Now imagine, for the first 30 days, there should be a discharge of 0.046. For the remaining 90 days, you require 0.029 cubics. So, what should be the minimum capacity of the canal to satisfy these requirements? It should have a capacity of 0.046 cubics, right? Because during the first 30 days, the canal should be able to supply this discharge. So, even if it is mentioned minimum discharge, what they mean by that is the canal should have at least a capacity of 0.046 cubics to satisfy the crop requirements. Okay. So, the answer for this question is 0.046 cubics. Now, just see the bracket, what is instructed to you. The answer should be in meter cube per second and rounded off to 3 decimal places. So, if you are writing the answer as 0.04, you won't be awarded any marks. So, you have to present your answer in 3 decimal place itself. Clear? Okay. So, I hope this question is clear. You are asked to find out the minimum capacity or the least capacity that a canal should have to satisfy the crop requirement. So, during the first 30 days, it requires 0.046 cubic, and for the remaining 90 days, it requires 0.029. So, definitely the canal should have at least a capacity of 0.046 to satisfy this requirement. So the answer 0.046 cubic. So, the question is actually a tricky question. So, since we are given it is the minimum discharge, you don't choose 0.029. Because if the canal has a capacity of 0.029, it won't be able to supply water during the first 30 days. So, the meaning is the canal should have at least the capacity of dash to satisfy this requirement. So, 0.046 cubic. Now, let us move on to another question. A similar question. For a canal, GCA is 5,000 hectares, out of which 20% area is unculturable. What does that mean? You have a total area of 5,000 hectares, and among that area or in between of that total area, 20% is not fit for cultivation. So, how to find out CCA? GCA minus unculturable areas. So, we will see the steps later on. So let us move on to the question. The intensity of irrigation is 40% for wheat and 20% for rice. You already know what is intensity. The portion of CCA which was irrigated during 1 year. So here we are considering 2 seasons. For wheat, 40% of CCA was irrigated, and for rice, 20% of CCA was irrigated. So initially we have to find CCA. How to find CCA? GCA minus unculturable areas. From that CCA, you have to find out the area irrigated for wheat and area irrigated for rice. Outlet discharge factor for wheat and rice are 1850 and 1200 hectares per cubic. So you already know that outlet discharge factor. Seeing the units itself, you can tell it is duty. So outlet discharge factor is another word for duty. Okay, so duty is also given. You are asked to find out the discharge at the head of the canal, neglecting all losses. So here the important point is, we are talking about 2 crops, rice and wheat, which belongs to 2 different seasons. Wheat is a rabi crop and rice is a kharif crop. Okay, so that means that we are not supplying water simultaneously. We are supplying water to both these crops during different time period, right? We have to supply some amount of water in the rabi season and another amount of discharge in the kharif season. And we are asked what is the discharge at the head of the canal. So got it? So initially also I told you that the awareness of crops is very important in solving such problems. You have to observe whether you are supplying water to 2 different seasons or to the same seasonal crops. So here the crops belong to 2 different seasons. Now let us find out the discharge required for wheat and discharge required for rice. Okay. Let us see. So initially, as I have already told, GCA is 5000 hectare. I am going to find out CCA. GCA minus unculturable area. Here 20% of area is not culturable. So you get CCA as 4000 hectare. So now since we have CCA, we can easily find out the portion of CCA irrigated for wheat and rice. So area irrigated for wheat is 4000 into 40 by 100. We have been told that 40% is the intensity for wheat and 20% is the intensity for rice. So we get the area irrigated for wheat and rice as well. Now we are going to find out the discharge. The discharge for wheat is found out by area by duty. So area irrigated is 1600, duty is given as 1850. So you get the answer as 0.864 cubic. Discharge for rice is similarly obtained as 0.667 cubics. Now see, you have 2 discharges with you. Which should be the discharge at the head of the canal? You are irrigating during 2 different seasons, that is rabi season and kharif season. So during rabi season, you have to provide 0.864. During kharif season, you are providing 0.667. So what should be the capacity of the canal? It should be the maximum of both the values. Why? Because you don't have to provide these 2 discharges at the same time. You are providing it during the different time period or different season. So if it was wheat and mustard, then the case would be different. You have to take the sum of both the discharge. But since this is provided during 2 different seasons, you can take the maximum value. Got it? I hope it is very clear. You have to provide a discharge of 0.864 during rabi and during kharif you are providing only 0.667. So you are providing it during 2 different time zones. So if it was the same season and same crop, for example, you are cultivating rice and cotton. So rice and cotton belong to kharif crop. So both the discharges are to be added because you will be providing the both discharges at the same time. So the canal should have a capacity of sum of discharge. But since here it is 2 different seasons, you can take the maximum value, that is 0.864 cubics. So please note, if the crops belong to 2 different seasons, you have to take the maximum. if they belong to same season, you have to sum or you have to add up both the discharges. Clear? So that is the importance of this question. Rice and wheat are given, that is Rabi and Kharif is given. So you are taking the maximum of both the discharges since you don't have to supply it at the same time. But if the same crops for the same season are given, then you have to add the discharges. Clear? So here the answer is 0.864 cumex. Now moving on to the next question. In an irrigation project in a certain year, 70% and 46% of CCA in Kharif and Rabi remained without water and rest of the area got irrigation water. The intensity of irrigation in that year was, so we have already discussed that what is intensity. It is the percentage of CCA irrigated in 1 year or irrigated annually. So you are asked to find out intensity. This is an ESC question. Actually, it is very simple because you are told that 70% of area of Kharif remained without water. That means 30% of area got water. And for Rabi, 46% remained without water. Again, it means 54% got water or you irrigated 54%. So what would be the intensity? 30 plus 54 is equal to 84%. Let me show you the steps. Area irrigated in Kharif, that is 100 minus 70 equal to 30% because we are told that 70% remained without water. So 30% got water. In Rabi season, 46% remained without water, which means 54% got water. So intensity is the sum of both the season. 30 plus 54 is equal to 84%. So you may be wondering what is so different about this question. This is a conceptual question. Only a student who knows clearly what is intensity would be able to answer such a question. That is why I have included this question also. Now let us see another problem also. This is again from GATE and this is an MCQ question. What is an MCQ question? That is multiple choice question. You will be given 4 options and you have to choose the right one. And if you have chosen the wrong answer, there will be negative marks also. 1/3 marks will be deducted from the total marks. Okay. That is, if this question carries 1 mark, 1/3 will be deducted. And if this question carries 2 marks, 2/3 marks will be deducted. Now let us see what the question is about. Wheat crop requires 55 centimeter of water during 120 days of base period. The total rainfall during this period is 100 mm. Here you have to be careful. Irrigation is the process of artificially supplying water for growing crops. Now if rainfall is available, you have to provide only the remaining water. Here 10 centimeter or 100 mm of water is provided by rainfall. So you don't have to supply artificially 55 centimeter, 10 centimeter will be provided by rainfall. So remaining has to be supplied by us. That is 55 minus 10. 45 centimeter is the delta to be artificially provided. Assume the irrigation efficiency to be 60%. The area of land which can be irrigated with a canal flow of 0.01 cubic. This is actually a very standard question. You are asked what is the area which can be irrigated if you are going to supply 0.01 cubics of water. Now let us see how to solve this problem. So as I have already told, the delta of irrigation water, that is the total depth requirement is 55 centimeter. But since there is a rainfall of 10 centimeter, you are going to apply only 45 centimeter of water. That is 55 minus the rainfall, 10 centimeter, 45 centimeter. So we have base period of 120 days also. So you can find the duty. So duty is equal to 864 B by D. You get the answer as 2304 hectares per cubic. I have already explained what is duty. the area of land in hectares which can be irrigated using 1 cubic of water. So from this answer, you can conclude that using 1 cubic of water, you can irrigate 2304 hectares. But the question is, what is the area corresponding to 0.01 cubic? It is very easy. So, for an area of 0.0, for a discharge of 0.01 cubics, what would be the area? 23.04 hectares. You got the concept? Duty means the total area which can be irrigated using 1 cubic. You got the answer as 2304 hectare per cubic. That means using 1 cubic, you can irrigate 2304 hectares. So that means using 0.01 cubics, you can irrigate 23.04 hectares. But that is not the final answer, because in the question, it is given that the irrigation efficiency is 60%. It has not been mentioned whether it is a conveyance efficiency, application efficiency, or some other efficiency. So you can assume that it is supposed to be the efficiency of area, which is the unknown quantity which we have to find. So the efficiency of area is only 60%. So what we have to do is, we have to take the 60% of area. So using 0.01 cubic, you can irrigate 23.04 hectares. But since it is mentioned, only 60% of area is efficiently used. The answer will be 23.04 into 60 by 100, which is 13.82 hectares. So our answer is option A, 13.82 hectares. I hope this problem is very clear. This is a very standard question using the basic concept of duty. So if you know what is duty, this question is very easy, because duty is the land which has been irrigated using 1 cubic. They are asking you what is the corresponding area for 0.01 cubic, provided the efficiency is only 60%. I really hope this session was very useful to all of you. I hope the theory concepts and the problems has been explained well. So all the best for all of you for GATE 2025. Thank you for joining.
Start your preparations for engineering competitive exams from top educators. Learn from the best.